Hey gang, it's me back with another screencast. Wanted to talk a little bit about how to use Excel to do some joint probabilities and cross tabulation exercises. So this is the example from page 140 in your book. And what we have is some survey results. They asked both undergraduates and graduates whether a four-year degree was very important, important, or not important. So we have those three categories of answers and two categories of respondents. And before we go any further, we're going to want to get the totals for each of these. So I'm going to make a total row here. And then here I just need to add up the people who said that it was very important. So there's the 100 plus the 80 here, and then I can go back to here and copy that, drag it over here, paste that as a function. Great, and that creates my row totals right there, my column totals rather. Now we need to do row totals as well. So we just get the sum of this row of numbers here. From there, copy that formula and paste it here. Great, so now notice I've got some new information now. It turns out my survey asked 180 undergrads and 220 grad students. Total 180 people thought this was very important, etc. And then this bottom, the total of the totals, this tells me that there were exactly 400 people who answered the survey. So now what we want to do is create another table which answers the questions about probability. Given this survey, what are the odds that if you asked someone they said it was very important? And then the joint probabilities, what are the odds that if you asked an undergrad they would have thought it was very important, or if the person you asked was both an undergrad and thought it was very important. So we need to make another table with the same exact labels. Copy that, paste it down here. Row options there. All right. Now what we want to do is translate this table, except instead of saying 80, I want to say that's 80 divided by 400. So for this cell, I'm going to say that's equal to this cell here divided by the total cell. That's cell E5, giving me the total number of people who answered the survey. And because I'm going to copy this formula over, but I always want to divide by that same cell, again, I'm putting in the dollar sign so that E5 is held constant, but the cell in the numerator can change. So now that's my formula there. So that 0.2, that says that of the people who took the survey, 20% were both undergraduates and thought it was very important. And I'm going to take this formula, copy, and I'm going to drag it the same amount, the same size here, and then paste function. And there we go. So now we've got our complete probability data about the survey we did. We noticed that this total undergrads, this says that 0.45, 45% of the students surveyed were undergraduates, and that 55% were graduates. Notice the total is 1. That means that's the 400 divided by 400. So we've got 45% of students overall thought this issue was very important, and 20% of students were both undergraduates and thought it was very important. So you can just read off all the data here from the probabilities, and this helps you answer questions about what are the odds that if the student thought it was important that they were an undergraduate or a graduate, that sort of thing. Anyway, hope you found that helpful, and I'll talk to you soon about quartiles and outliers. Anyway, talk to you guys later.